Thank you all for coming today. It's my pleasure to introduce Oscar Levin, presenting on accessible and interactive course materials with PreTeXt.
Thank you very much, Gavin. Thank you all for being here, and thanks to the organizers for inviting me. I want to tell you about some recent work that I've been doing on a project that I didn't start, but I'm a huge fan of, and that is PreTeXt. I assume most of you have some method for creating course materials. The people at this expo are not interested in just using publisher materials and going with whatever they're handed. I imagine you want to create stuff specifically for your students. And I'm going to suggest that using PreTeXt is the right way to do this. And soon will be the way to do it. So I'm going to start with just a little overview about what PreTeXt is and why I think it is so great. And then I will actually show you some stuff about just how easy it has become to use PreTeXt. Okay. Oh, I should say, if you want to look at these slides, some colleagues and I have started a website called mathtech.org, and if you go there, that's this one here, PreTeXt for Courses and Slideshows. There's a link to these slides. These slides were created with PreTeXt, creating a Reveal.js slideshow. Okay, so the future of course material creation. Let's think about how you want to distribute materials that you create for your own courses. How do you share those with your students? Well, some older technologies, you could write everything down on papyrus scrolls or stone tablets. I think we're a little beyond that now. You could take the journal approach, the old journal approach, where you typewrite your notes and then you hand draw math symbols in there. Or maybe you just handwrite things and you run them off through the copier and hand them out on paper to the students who happen to be attending that day. Maybe it's a little more modern. You use LaTeX to generate PDFs and you post that on Canvas or whatever your LMS is, but then you get yelled at because they fail accessibility tests, right? PDFs generated by LaTeX are not generally accessible. And today more than ever, we need to make sure that these are accessible. How about we make our materials available on everyone's phone or tablet and from any website and make them fully accessible? I think that is the way that we should be operating. I imagine a lot of you write stuff in LaTeX that has been the de facto standard for creating any sort of document with mathematics in it, but I think there are some limitations. The big one for me is that LaTeX output is generally not accessible. There have been a lot of strides made recently to correct this, and the always 2 years away LaTeX 3 is supposed to be pretty good at creating tagged PDFs. We've tried out these recently, and while it does do some good tagging of things like headers and sections, any math in it, the screen reader just completely chokes. So even that, PDFs just, I don't think, are the answer. Plus, I don't know if you've ever tried to read a PDF on your cell phone, zooming in and scrolling back and forth to read an entire line. It's miserable. HTML is really the better way to go than PDF. But getting HTML out of LaTeX is a really hard problem. Archive has thrown a lot of money into this and a lot of effort because they want all of their research articles to have accessible HTML versions. Still, because LaTeX is so flexible, about 25% of the papers that are submitted have some sort of errors, many of those not even compiling to HTML. From a pedagogical standpoint, I think the problem is, in a LaTeX document, how are you going to embed a YouTube video you recorded demonstrating something? How are you going to run computations for the students right there for them? Or include some checkpoint assignments that they do before class? That you really can't do in a LaTeX document. A big problem, I think, is that LaTeX lets you do too much customization. It takes time away from what you should be doing and focusing on the content when you're trying to get every little margin exactly how you like. One of the original appeals for me of LaTeX when I first started grad school was, hey, I can just type this up in a plain text document and it produces something that looks beautiful. But then once you get that, you say, oh, you know what would be even more beautiful is if I had a little more space right here. And then I spend a week trying to make my own LaTeX style file instead of actually writing my dissertation. So I think that is a problem with LaTeX as well. I would like my tool for creating these to get out of my way and just let me focus on the content. So I present a better way, and that is PreTeXt. PreTeXt is a semantic markup language designed for scholarly documents. It definitely has its roots in creating open educational resources for mathematics, but the goal is to go beyond that. The motto of PreTeXt has been write once, read anywhere. You write source one time, and then you can read it in lots of different places. You could create HTML output that is accessible to screen readers. You can still convert to PDF through LaTeX. You could create an EPUB version. You could create a Braille version if you have a blind student, all from the same source files. Now, there are not, PreTeXt is not without its challenges. Some of the cons are, at least it has been, difficult to write in PreTeXt. This is a common complaint. The syntax is a little more complicated than LaTeX, but I think we all remember going through that steep learning curve of learning all the commands for LaTeX, and I imagine by now we're all just really good at it. And the same thing happens with PreTeXt, I assure you. Another complaint I sometimes hear is that while PreTeXt is fine if you want to put in all the effort to create an OER textbook, if you're going to write a whole textbook, that steep learning curve is worth it. But is it good for creating just a single worksheet for your class or small materials for your course documents? And my recent work, in fact, my current sabbatical work, is to try to make both of these two cons disappear. Just a little bit about the markup of PreTeXt. On the top here, we have a typical LaTeX fragment. You have begin theorem, you have a title for the theorem. You have to remember that the titles for theorems go in square brackets, not curly brackets. You have a label for it to refer to it later. Use $signs to denote mathematics. And then end theorem, begin proof, and then you write the proof. This exact same output can be achieved in PreTeXt. It's almost cut off there. Just a little smaller. It's still not going to show everything. Okay, so you have, this might look a lot like HTML. PreTeXt is XML, is the source format, essentially. You have a theorem. The XML ID takes the place of label. You have a title, but you know it's a title because it's in title tags, not just happens to be in square brackets. You have a statement of the theorem. You have a single paragraph. The math is done exactly the same way. Those curly braces aren't needed. I don't know why I still have those. And the exponents there. You just use it with M tags instead of $signs. Between the $signs, PreTeXt and LaTeX are identical, almost. A proof belongs in the theorem because it's part of the theorem, so it's structured that way. So it looks really very similar. And once you get used to these tags and you use an editor that does good autocomplete with these tags, it's, I think, faster to write, or just as fast to write PreTeXt as it is to write LaTeX. There's a big advantage, though, to the syntax for LaTeX, and sorry, for the syntax for PreTeXt, because there's only one syntax for PreTeXt. There's only one correct way to do it. You're describing the semantic structure of your document in a way that can only be done in that one way. Whereas in LaTeX, you can do lots of customizations. So for example, this is the same LaTeX we just saw. This is LaTeX that is supposed to produce exactly the same thing. But let's see, the author of this particular thing redefined the begin theorem to be BE/T. That's a new environment they created. They use squiggly braces for their title. They don't even put a label because this is like a 3-argument environment they created with BE. And then to end the theorem, they just do \ET. Let's see, the math is the same. Oh, but they're going to use the Pythagorean triples so often that they created a macro that you don't even need $signs. You do \PT XYZN, and that's how you get the Pythagorean equation with exponent n and variables x, y, and z. Okay, cool that you can do that, but the problem is if you're working with a colleague and they typeset their materials using all these macros, and you want to copy that in and use some of it because they're sharing it with you, what are you going to do? You have to go through line by line and fix every little idiosyncratic change that they have made. would be much better if you could be assured that the source code that they're using will work in your document without fail. Okay. PreTeXt has evolved quite a bit over the last few years. As a project, it's about 12 years old. It started out as MathBook XML. Perhaps some of you have heard that. It used to be, before 2020, the steps to compile a document included cloning the PreTeXt repository from GitHub. You had to run the PreTeXt script, so you had to remember a command that looked something like this. Python, and then the path to PreTeXt. Double V, I think, is for very verbose output. The component that you want to build are LaTeX images. You want to have the format SVG. The output is, and it keeps going. Once you're done with that, you have to use a program called XSLTproc to process the PreTeXt. That is easy to do if you're on Linux or Mac, because it comes with it. On Windows machines, that's very difficult to install. There is a way. And you do that, and you have to, this is actually not even correct. This has to be a path to the source of, to the PreTeXt repository. And then the view output, you have to upload it to a web browser to actually see what it looks like when it's being rendered. So one of the projects that I've been working on for the last 4 or 5 years has been to let you do all of this just by clicking some buttons in VS Code. So let me show you. So let's say you wanted to start a new PreTeXt project. What you're going to do is you would go to this website, github.com/pretextbook/pretext-codespace. There are links in the rest of the presentation if you want to grab those at some point. You're going to go to use this template. I've made my web browser a little big. Usually it's over there, but use this template and create a new repository. When you click on that, you'll be taken to a page where you can name your repository whatever you want, maybe PreTeXt course demo. You do. Now, that's already created because I already created one. You go there, you hit create repository, and you're taken to a page that looks something like this. So this is based on the template. You have everything you need. And then if you want to do everything in your browser, notice I'm just in Chrome right now. Everything we're doing just is in Chrome. You don't have to install anything on your computer except Chrome. You, of course, can install this on your computer and do it locally, but it takes a few extra steps. Go to code. What you would see normally there is something that looks like this. This code button would say create code space on main. And when you do that, mine's already open, so I can click on it. I did it ahead of time because the first time you spin up a code space, it takes about 5 minutes to load all the software. What's actually happening is GitHub is creating a virtual machine for you on their servers and installing all the software you need for PreTeXt. So they've done all the installation for you, and you get what looks like a Visual Studio Code window here. You use Visual Studio Code for any editing. Any text editing is great for. And this is, you get something that looks just like this, and it has a template for PreTeXt. Now, I've done a few changes at this point to make it into the course template. That's something that I still need to set up to make that a little easier, that process, so you can just select it. But what I have here is my main.ptx folder. It's inside a source folder here. And it's an XML document. You see, let's make this even bigger. There we go. So you see that we have an XML declaration, we have a main PreTeXt element, and then we are including stuff. So you can use modular files like you might be used to doing for LaTeX with an import or include. So we're going to have some doc info. This is where you would have kind of your equivalent of a PreTeXt, of a LaTeX preamble. You can define some macros. Macros for math work just fine. And then we have a book. I'm creating a book that is basically going to be a course myself. I have some front matter, a syllabus in there, some course notes, and some activities. This is stuff that all comes with the course template. Okay, so let's see what that looks like. Now, I don't have to type any commands on the command line, although I could, and they're not too difficult. It's PreTeXt build. That's all you have to do. Instead, I'm just going to go down here and click the PreTeXt button. It says run PreTeXt command. I'll do that, and I will go to build default target. And hopefully, oh, there it goes, it's running. It takes just a minute to compile this, just like if you were to compile LaTeX. Oh, it's done, success, I can preview my output now. Well, let's go back to the PreTeXt button, and let's view full document. And I'm viewing the target web. Do that, and just refresh that. Connecting to the forward report. Again, this is all in the web browser. It opened up a new tab. I have dark mode enabled by default in Chrome, but if I didn't, it would look like this. And here we see, okay, this is a demo course. I have a syllabus here. There's not much information because I haven't added anything yet. I can go to the next thing, which are my course notes. I've set up week 1 and week 2, but I could easily add some more, of course. Go to week 1, I see, oh, there's what I have, and this would be filled in during the course of the semester as I go. Maybe I have some in-class activities. Okay, so here's one that's Magic Beans. This is one from my discrete class. I have this. Now, this is not an interactive one, but I could make some interactive stuff in there if I wanted. I could also, by going to US there's some weird coloring here just to show me that I don't have the spacing quite right. But I can go to print it, and it should print a version of that. Oh, of course it doesn't now, but it's supposed to print a version of that where the spacing is correct. Okay. So I get all of that just from the main source file. To give you an example of what that Magic Beans activity looks like, how you write that, that would be up here in it's one of the activities, Magic Beans. So I wrote an introduction to it. There is a paragraph there that actually has the content. I have for that. Then I have a page that has describes. I have workspace of 1.5 inches. That's how I get some workspace. And then I have my activities as individual exercises inside that worksheet element. Okay. The way I set this up, what I could actually do, and this is something that's still in progress, some work I'm doing, I could get a PDF directly of this. The way that I'm going to do that is I'm going to, in the terminal, type PreTeXt build, and then I'm just going to go to that particular thing. So this is going to be source, activities, Magic Beans. I build that, and it's now compiling the LaTeX. Now it's done, and you'll see now I have a PDF of this. Which should maybe you'll just have to trust me. Of course, as soon as you start doing a presentation, all these little things take way too long. There it goes. So there it is as a PDF, and it looks nice. That would be something I could print out and bring to class. Okay, so I did view. If I want to actually share this with my students, what I could do is go down here to PreTeXt and go to PreTeXt deploy. And that's going to run. And what that has done is that has published the course notes that I've created to my course website, which is hosted for free by GitHub using GitHub Pages. I'm not sure it's going to pop up now, but if you went to, let's see, let's do it this way, just so I can get that message. Well, the point is that it would be on a live website that anyone could access. That one that I viewed here, that was just a preview. So it would be just like this, but it would be at something like, in my case, it would be oscarlevin.com/pretext course demo. Okay. What other sort of content can you have in here, very briefly? This is from my discrete math book. And this is the type of thing that you might want to put just in your course notes even. So this is the Towers of Hanoi for the beginning of sequences. This is a GeoGebra applet that I found on the GeoGebra instructor website. To get this in my PreTeXt document, all I did was have figure, I gave it a caption, and then I gave it an interactive. GeoGebra equals, and this was just the special code that was on the GeoGebra hub thing, whatever they have. That's it. That's all I had to do for that. And what you could do is, if you wanted something like this, you could go to my GitHub for the discrete book. You could go find this file. You could copy this. There's a static version that's in TXT there. You copy that, and you can paste it directly into your course notes, so that when you build that, you will get exactly the same thing. After that, what I like to do is I like to assign a preview activity before class. This preview activity is, this is all authored in WebWork. So what is the pillar with the smallest number of moves required to, or what is the smallest number of moves required to transport 2 disks to other pillars? That happens to be 3. I can check my responses. That's correct. I go on to the next task. Later in this section, I suggest that perhaps you want to use Python to do some exploration of sequences. So I give them an example of some Python code. You define the function a that returns 2 to the n minus 1. And I want to print what a3 is. I can run that, and it shows me that, oh yes, it's 7. And of course, then students could do that and say minus 2, and they could change it however they want. You can go back and forth. Perhaps something more interesting, if you want to get all of them. This example of getting the entire sequence. There's this cool show in code lens thing. If you are teaching programming, when you run it, you can say exactly what each line of code does. To get this in the book, what did I have to do? This is being near the bottom. Sorry, that's making you seasick. Here, let's. So the first program was just this, those lines. Program, interactive active code, language was Python. I gave it a label, and I just said what the code was. And everything else was done automatically for me. If you want to see other examples, there are a whole bunch in the sample article for PreTeXt of interactive elements that you can author directly. Oh, yep, there, if you want to play with some vectors. You want to do some linear algebra scaling stuff. And the source for this is pretty complicated because you're actually writing some sort of JavaScript code. But you could do that. This is more JavaScript. Cool. Try to make the graph planar. Drag stuff around. Let's see. If you want to rely on things that other people have written, there are interactive elements. There's something like the GeoGebra that we had, the GeoGebra thing that can load. You can put Desmos graphs. You can actually have a Desmos calculator right there for you. CalcPlot3D, which I think we'll hear about in about 5 minutes. You can embed CalcPlot3D in there and all sorts of other things. Lots of different types of interactive exercises. In addition to WebWork, it's easy to do true, false, or multiple choice. If you teach proofs, or I imagine differential equations, you want to go through the steps to solve something. You can drag things over, try to put them in the right order, check to see that that's right. No, obviously not, because I wasn't paying attention. If you do it 3 times, you can get some help. So lots of fun stuff to play around with. SIMIODE's textbook is written in PreTeXt. That is not open source. You have to pay for it to get it. If you want to supplement that with another ODE textbook, Thomas Judson has been working on the ordinary differential equations project, also in PreTeXt. This has Sage code in it, much like the much like the SIMIODE textbook. So you can see things where you can try to run Sage code. Again, all you have to do to write this in PreTeXt is basically write the code, and then it can evaluate Sage. I don't think I've initiated it correctly. Yeah, there's something else that I had to do earlier up. So that gives you some idea of the types of things you can do in PreTeXt. I think this would be helpful for your individual courses where you can create materials. If you get to the point where you write a textbook, there is a hosting service for PreTeXt book that's completely free called Runestone, where those interactive exercises I showed you can be tracked. So if you have a full textbook eventually, you can put that up on Runestone, and then you basically get a learning management system that keeps track of student work inside the textbook. So with that, we did demo time. Just a brief thing about the future. We're going to try to improve the templates for the courses. We're going to have better conversion from LaTeX. You probably have LaTeX materials. We're going to be able to convert those to PreTeXt better. Maybe you can even type in LaTeX if your fingers know that, or Markdown. And eventually, we're working on what you see is what you get sort of editor, so you don't have to learn as many tags. So thank you all. I'd be happy to answer any questions that you might have.